So today's video we are going to see Lagrange method for two variables. So here we are going to find the maximum or minimum of f of x comma y, which is subject to the constraint g of x comma y. So you will be asked a question, find the maximum and minimum for a given function, and you'll also be given a constraint for the question. So here is the procedure how you find the maxima and minima. So step 1, you have to first write your capital F of x comma y. You are given your small f of x comma y, g of x comma y. With that, you are going to write your capital F of x comma y. So how do you write this is, you have to write f of x comma y plus lambda into g of x comma y. So you have to combine your small f and small g, and you have to write this function. Next one, step 2, you have to find the first derivative with respect to x and with respect to y. Step 3, you have to equate the derivatives to 0. Step 4, you have to solve this f of x is equal to 0, f of y is equal to 0, and bring it in terms of lambda. So for further proceeding, it will be easy. So you will solve f of x is equal to 0, f of y is equal to 0. Then to find x and y, you solve g of x comma y is equal to 0. Okay, and finally in step 5, the stationary value is obtained. For the points x comma y. Okay, so we'll do a problem. Find the maxima and minimum value of the function f of x comma y is equal to xy, which is subject to the constraint 4x square plus y square is equal to 8. So you are given the function, you are also given the constraint. So first what you do is, you have to write your capital F of x comma y. Step 1, right? What is your capital F of x comma y? So capital F of x comma y is nothing but small f of x comma y plus lambda into g of x comma y. Okay, so from the given question, your f of x comma y is nothing but xy, and g of x comma y is nothing but, it's given as 4x square plus y square. Here you have plus 8, when it goes to the other side it will be minus 8. Okay, so now I write what is my f of x comma y. So f of x comma y is nothing but xy plus lambda into 4x square plus y square minus 8. So this is my f of x comma y. Next I have to write, I'll just bring lambda inside. So it will be lambda 4x square plus lambda y square minus 8 lambda. This is my f of x comma y. Step 2, I have to find what is fx of x comma y. Likewise, I have to find what is fy of x comma y. So fx of x comma y is nothing but the given equation. I have to differentiate with respect to x. So differentiation of xy is y plus 4 and lambda will come as it is. Differentiation of x square is 2x. Here you can check there is no x term. So differentiation of a constant is 0. So this is y plus 8 lambda x. This is my fx. Okay. Next here fy of x comma y, you can write it as the same equation. You have to differentiate with respect to y. So differentiation of xy is x, and the second term doesn't have any y, so this is a constant. Differentiation of a constant is 0. Now this term has y, so lambda y square, when you differentiate it will be 2y lambda, And finally, last term doesn't have any y terms, so the derivative of that will be 0. Okay, so now this is my fy. Fy is x plus 2y lambda. Okay, so now what I have to do in my step 3 is I have to equate it to 0. That is, I have to equate fx is equal to 0 and fy is equal to 0. So when I equate this, I'll get y plus 8 lambda x is equal to 0. From this, I have to write what is my lambda. So I'll be having 8 lambda x is equal to minus y, or lambda is equal to minus y by 8x. Similarly here, have to write fy is equal to 0, so which implies x plus 2y lambda is equal to 0. From this, if I am writing lambda, it will be minus x, so lambda is equal to minus x divided by 2y. Okay, here I got a lambda, here again I've got a value for lambda. So now both are lambda values, I can equate the lambda values. So here I take minus y divided by 8x is equal to minus x divided by 2y. So here minus and minus will get cancelled. If I cross multiply, I'll get 2y square is equal to 8x square. So 2 ones are 2, 2 fours are 8. Okay, so I'll get y square is equal to 4x square, or y is equal to plus or minus 2x. Okay, so this is my value for my y. Now what I have to do is my next step. That is the continuation of step 3. I have to solve and I have to find the values of x and y, taking g of x comma y is equal to 0. So here in this problem, my g of x comma y is nothing but I have to take g of x comma y is equal to 0 and find my x and y. So here in the given problem, g of x comma y is nothing but 4x square plus y square minus 8 is equal to 0. Okay. So now what I have to do is, I know that y is taking two values, plus or minus 2x. So instead, if I substitute here, if I am substituting y is equal to 2x, I'll be having 4x square plus 2x the whole square minus 8 is equal to 0. So I'll be having 4x square plus 4x square minus 8 is equal to 0, or 8x square minus 8 is equal to 0, or 8x square is equal to 8, which implies x square is equal to 1. So which is x is equal to plus or minus 1. Suppose if I am taking y is equal to minus 2x, my equation will be 4x square plus minus 2x the whole square plus minus 8 is equal to 0. So 4x square plus 4x square minus 8 is equal to 0. You can see that I get the same equation. So it is enough if I solve one equation. Okay. So now what I've got is, I've got y is equal to plus or minus 2x and x is equal to plus or minus 1. Okay, so y takes the value, if y is equal to plus 2x. So here, when I substitute x is equal to, x is taking values plus 1 and minus 1. So when y is equal to plus 2x, what happens is, when y is equal to plus 2x, I am taking x is equal to plus 1. If I am taking x is equal to plus 1, y will take the value 2. And when x is equal to minus 1, because x is taking the value plus 1 and minus 1. So if x is taking the value minus 1, so instead of x, if I substitute minus 1, y will take the value minus 2. Okay, likewise, if y is equal to minus 2x, so again you can see that x is taking the value plus or minus 1. So now if x is equal to 1, so to x, right? So if x is equal to 1, what will happen to my 1? So y is equal to minus 2 into 1, so it is minus 2. And when x is equal to minus 1, you can see that y is taking the value plus 2. Okay, so these are all my critical points. Therefore, the critical points are so when x is equal to 1, y is taking the value 2. X is equal to minus 1, y is taking the value minus 2. If x is equal to 1, y is taking the value minus 2. And if x is equal to minus 1, y is taking the value 2. So these are my critical points. So after this, I'm just going to find what is my f of x comma y at these points. So at 1 comma 2, if I'm taking the first point, my f of x comma y, my f of x comma y is nothing but xy. So if I substitute x is equal to 1 and y is equal to 2, it will be 1 into 2, which is equal to 2. At minus 1 comma minus 2, my f of x comma y, again it is xy, which is minus 1 into minus 2, which is again plus 2. Now at the point 1 comma minus 2, you can see that f of x comma y is xy, which is 1 into minus 2, which is equal to minus 2. And finally, at minus 1 comma 2, f of x comma y, which is equal to xy, will be equal to minus 1 comma 2, which is equal to minus 2. Okay, so you can see that above all the four things, I get plus 2 times and minus 2 times. So that is, here compared to the four values, plus 2 is the maximum value and minus 2 is the minimum value. So you can write the maximum value of f of x comma y is equal to 2 and it is attained at the point minus 1, sorry, 1 comma 2 and minus 1 comma minus 2, and likewise the minimum value of f of x comma y is minus 2 and that is attained at one comma minus 2 and minus 1 comma 2. Okay, so this completes the proof.